The following program is rated PG and may contain scenes of violence, nudity, coarse language, and mature subject matter. Viewer discretion is advised.
Humanity has always lived with nature's destructive potential. Natural disasters loom on mountain peaks.
Nothing is surviving something like that. It's going to obliterate anything in its path.
And lurk under sea floors.
Tsunami waves travel extremely quickly.
Some of the biggest perils are of our own making.
This interruption came at an incredibly inopportune moment.
From disrupting global supply chains to unleashing atomic chain reactions.
The first thing is bright flash, and then right behind that shockwave is the fireball.
Those who died on contact were the lucky ones.
And now, the exponential transformation of our very climate.
The fires began burning out of control.
Start running.
The challenges we face as a species have never been greater. More than 2 billion people live in countries bordering the Indian Ocean. The third largest of the world's 5 oceans covers over 70 million square kilometers. In the east sit dozens of islands that make up the nation of Indonesia. Indonesia's population is a staggering 270 million people. Of those, nearly 60 million call the island of Sumatra home.
The island of Sumatra is highly populated. There are multiple large cities, typically coastal cities. It's a region which has a lot of palm oil plantations and coffee production. The economy is typical of Indonesia. It's a fairly low to mid-level developing country.
Sumatra is also known for devastating natural disasters, such as the brutal earthquakes of 1797 and 1833. But the island was not ready for the events of 2004.
I personally remember when this happened. December 26, 2004, we began to hear reports of a massive earthquake 20 to 30 miles off the coast of Sumatra. This was an 8.9 to a 9.1 magnitude earthquake.
When you talk about a 9.1, that is getting up into the strongest earthquakes the planet has ever seen.
The earthquake was felt in Bangladesh, India, Malaysia, Myanmar, Thailand, Sri Lanka, and the Maldives.
In Banda Aceh, on the northern tip of Sumatra, they felt that earthquake for 8.5 to 9 minutes, which is absolutely unprecedented. Normally earthquakes are 15 seconds or 30 seconds.
It caused tremendous damage to many cities in Sumatra. But what was coming was much worse.
Almost instantly, we began to hear reports of the tsunami that was triggered from that earthquake.
Now, we often have in our minds that a tsunami is going to be this single towering wave that's going to sweep over. A tsunami usually isn't that. It's a series of several waves, and the first wave might not always be the biggest wave.
The fault zone ripped, a bit like a zipper. It's been described as a slow release of energy all across a 1,600 kilometer distance.
Think about the movement of a tsunami like throwing a rock into a pond. You'll see a ripple move outwards from that impact point, and it only slows down as it gets closer to land and begins to rise.
Waves shot outwards from the epicenter of the earthquake at a rate of about 800 kilometers per hour, or about the speed of a commercial jetliner. The coasts of the Indian Ocean were in incredible danger.
But the people of Banda Aceh had no idea what was coming.
One of the conditions that were seen immediately after the earthquake was the sea receding, and that's typically evidence that a tsunami is approaching. It's the low point in the wavelength of a tsunami.
If you had the education to understand what you were looking at, you knew that you had to be running. Not everybody had that education.
You can actually see in some cases people standing on the beach or going out to pick up shells, unaware of the danger, only to be caught up moments later as the water came rushing back to fill that void.
Start running. When the wave came, nothing was going to stop it.
The initial tsunami wave hitting Banda Aceh occurred about 25 minutes after the earthquake happened. Tsunami waves in the open ocean travel extremely quickly, but as they reach the shoreline, the leading edge of that wave begins to bind on the bottom of the ocean, and essentially it begins to slow, and the wave piles up. The maximum heights that have been recorded all around the shoreline were something like 25 to 37 meters, higher than a 10-story building.
As the tsunami violently came ashore in Banda Aceh, the wave appeared to be of deep black color. It devastated everything in its path: cars, buildings, and people.
Already weakened by the earthquake, buildings had no chance against the torrent of water.
It's a very dense medium. It carries a tremendous amount of energy. And all of that energy then gets transferred into buildings. It's just not survivable.
Helicopter surveys showed entire settlements virtually destroyed, with destruction many kilometers inland. Nearly 100,000 people were dead in Indonesia alone. But the Banda Aceh was just one region hit by this brutal force of nature.
500 kilometers away in Thailand, it was affecting not just locals but tourists. Many of them had come down to celebrate Christmas holiday season.
Thailand suffered a huge number of casualties, especially in the Phuket region. Most of the video footage that we have was shot by foreign tourists.
In total, the tsunami killed about 8,000 people in Thailand, but many more across the Indian Ocean would fall victim to this deadly disaster.
Outside of Indonesia, one of the hardest hit countries was the island nation of Sri Lanka, where approximately 35,000 people were killed and over 90,000 buildings were destroyed.
All along the east and western side of Sri Lanka, there's really no height of land to prevent the tsunami wave from traveling inland. There are literally tens of thousands or millions of people who are locating in that coastal zone within the first 100 meters or so.
The dissipating waves still had massive destructive potential by the time they reached East Africa.
By the time it strikes Somalia, it's still destructive because it's all salt water. Salt water itself is extraordinarily destructive to electronics, to vehicles, urban structures, to agriculture. You're now dealing with an environmental catastrophe.
In the end, the 2004 Indian Ocean tsunami killed approximately 230,000 people in 14 separate countries, making it one of the worst natural disasters in recorded history. But what made this tsunami so deadly? And how can science help us detect future mega tsunamis? This earthquake occurred along a 1,600-kilometer subduction zone where the Indian plate had slid under the Burma plate.
One tectonic plate is colliding with another tectonic plate until finally the strains release. That tends to produce a massive earthquake. In this case, one of those plates sprung up towards the surface, and water cannot be compressed, so the entire water column on top of that moves upwards at the same speed.
Sumatra is located in the region known as the Ring of Fire, an area known for its volcanic and tectonic activity. This region is no stranger to earthquakes, but the 2004 tsunami took most by surprise.
Tsunamis can occur in any of the world's oceans. However, between 1900 and 2015, only 5% of the recorded tsunamis actually occurred in the Indian Ocean. Many of the people in this area weren't aware that this was an actual hazard.
that awareness increased. This was the first event of this scale in the age of ubiquitous cameras.
Normally with a natural disaster that happens abruptly like a tsunami, you only hear about it afterwards and you see pictures of the aftermath. Billions of dollars of damage, lives that were lost, people that are missing. Numbers don't lie, but numbers don't hit you the same way a picture does. And that makes it a lot more personal. And this isn't the worst tsunami that's hit, but it is one of the first that got people to understand just how devastating a tsunami can be.
While awareness and detection have improved, tsunami prevention remains impossible.
Tsunamis are one of those catastrophic events that are very difficult to engineer for. Water energy is just so immense and it creates such huge amounts of pressure. Even if you're up on the second level of buildings, those buildings could collapse. It's a really, really catastrophic event that there's little you can do with, especially in remote places.
But after 2004, new measures were put in place to protect the coasts of the Indian Ocean.
When we think about tsunamis, we can't engineer them out. We can't get rid of them. It's very hard to protect against. What we can do is give warnings.
The primary component of this tsunami warning system is what is known as DART, or the Deep Ocean Assessment and Reporting of Tsunamis. This system enables instant and accurate tsunami forecasts by monitoring the ocean floor.
We can also have floating buoys that sense changes in wave height. Even satellites can pick up tsunamis. And all of this can be incorporated into models and systems. And then we hopefully give those people a tsunami siren, a radio signal that goes out to everybody's cell phone saying, tsunami, get to high ground. These are the things that can have a huge impact in preventing tsunami deaths in remote locations.
To defend the Indian Ocean's shores, Australia, India, and Indonesia are leading the way in efforts to ensure a tragedy on the scale of the 2004 event never happens again.
There wasn't a system set up to detect a tsunami, and that has changed since this point in time. Science has come a long way, so now, should an event like this occur again, warning can be issued.
Massive waves on the vast ocean are a perpetual threat. But following the Indian Ocean east leads to the Red Sea, where disruption to an area only a few hundred meters wide would also have global consequences. In ancient times, the Red Sea served as the seafaring artery between Egyptian, Greek, and Roman civilization to the cultures of the East. Today, this region's importance to global trade is even greater.
The Suez Canal was constructed in 1860 as a way to improve global shipping routes into and out of the Mediterranean. It allowed trade moving in or out of Europe to avoid the trip around Africa, saving thousands of kilometers and weeks of sailing.
The Suez Canal is really a modern engineering marvel. Prior to the Suez Canal, if you wanted to ship something from Asia to Europe or Eastern North America, you have to go thousands of kilometers south in order to come back north again.
When the Suez Canal is constructed, we are at the height of the age of steam sailing. Those ships, sometimes steel-clad but more often wooden, had a maximum size, and the Suez Canal was built for ships that size. It has only been enlarged slightly in the ensuing centuries.
Roughly 10% of the entire world ocean trade passes through the Suez Canal. Any blockage of this narrow channel would cause billions of dollars of damages to markets across the globe.
The Suez Canal is a dredged canal, and in many parts it's so narrow that ships can't pass side by side. Only one ship can navigate the canal at a time. However, in the middle of the canal, there's the Great Bitter Lake that will allow two ships to pass side by side. They have to be staged so that they make the transit the most efficient it can be.
On March 23, 2021, one of the largest ships in the world, the Ever Given, was about to enter the canal.
The Ever Given is departing Malaysia and trying to get to Rotterdam in the Netherlands.
This short trip represents a routine voyage, but a staggering volume of cargo.
Imagine the Empire State Building laid on its side. It's 400 meters long. You can store 20,000 cargo containers with up to 220,000 tons of mass.
The ship is required to squeeze through a channel barely wider than its own 60-meter beam.
In some places, the Suez Canal is only 200 meters wide. Because of the slope of the canal bottom, the actual navigable portion is much narrower. When ships move through the Suez Canal, they push a bow wave of water in front of them, raising the level of the canal in front of the ship. This creates a pressure difference between the front of the ship and the rear of the ship. There's a lot of hydrodynamic forces going on. The navigator has to be very precise to reduce the risk that that ship is going to run aground or impact the sides of the canal itself.
But within hours of entry, at approximately 7:30 a.m. local time, the Ever Given experienced a sudden sandstorm.
Dust storms are just like a front coming past, and right down close to the surface starts to pick up that dust. It's just a change in air mass. And the Ever Given is essentially like a building on its side. There's a tremendous amount of force, and unless you're prepared for that, or if you have any sort of engine issues, you're done. I mean, you're just gonna get shoved in directions you don't wanna go.
The Ever Given is pushed outside its safe path, but it's much more than just a bump against the shoreline.
When the Ever Given veers off course and starts to run aground, it doesn't stop immediately. It has all of this momentum, and that continues to push it up onto the shoreline and raise it up out of the water.
The ship is stuck. The domino effect of delays created is immediate. 15 ships who were traveling behind the Ever Given were stuck. 200 other ships waiting on both the north and south sides of the canal had to wait for them to be cleared before entering.
This interruption and its timing of when it took place, particularly during the global pandemic of the COVID-19 pandemic, came at an incredibly inopportune moment. There is actually a surge of need of particular kinds of equipment. Interruptions to supply chains create massive and impactful consequences on not just economic outcomes now, we're talking about health outcomes for a large part of the world.
Masks, hand sanitizer, gloves. It was really critical that we have those supplies, and now all of a sudden, a vital trade artery was restricted.
A few days after the accident, there were estimated to be over 300 ships waiting for the Ever Given to be cleared.
Certainly, the eyes of the international community were on this event. Different mechanisms had to be employed, tugboats trying to attempt different maneuvers. Obviously, you wanted to make the right technical decision on how to execute without further causing damage, but also getting to a quick and effective resolution to get that trade flowing again.
They tried tugboats, they tried excavators, etc., to get the ship unstuck, but it's really difficult to do. The ship would have been bearing a huge amount on the soils that were under it, and excavating under this huge ship is going to be very, very difficult.
Nothing humans could throw at the problem was working.
The Ever Given was finally refloated, partially because of nature taking its course.
On March 29th, 6 days after the Ever Given was grounded, the water level increased enough to refloat the ship.
That allowed the tugboats that were working on getting the Ever Given unstuck to reposition it and unblock the Suez Canal.
The ship was taken into custody by Egyptian authorities and only released after SCA, the ship's owners, paid an undisclosed sum for the damages caused. In total, it is estimated that the cost to global trade was over $2 billion for the 6 days the ship was stuck. But how exactly did the ship get stuck to begin with?
The largest ships about 20 years ago were the Panamax II ships. Those could carry about 5,000 to 8,000 cargo containers. 20 years later, we have ships like the Ever Given, which can now carry 20,000 cargo containers. Cargo containers recently have been used for a lot of different things, including building small modular homes. That's the equivalent of 20,000 of these small modular homes. This is a huge increase in the size of these ships. They really are extremely massive.
But how can ships as large as the Ever Given even float? They do so using Archimedes' principle.
Anything to float has to displace a mass of water equal to the mass of the object. We have to make sure that there's enough air volume in the hull below the water level to match exactly the weight of the ship and the cargo. This is Archimedes' principle at work. What happens when a ship runs aground is it can no longer displace the required volume of water because it's actually sitting on ground. So in order to get the ship floating again, we actually either have to move the water up or remove the soil from under the ship so that it can again displace that water and be refloated. Ships really don't have the power to pull themselves back from being grounded. They usually either have to be mechanically removed or wait for a high tide to refloat them.
Ultimately, what freed the Ever Given was not force created by humans, but one created by nature, the tides.
When ships run aground, a lot of the time all we do is wait. That's what happened with the Ever Given. A large spring tide came in, water flowed into the Suez Canal, the ship naturally refloated on its own and became unstuck.
The Suez Canal is a key part of global trade networks that make the privileges of modern life possible. But globalization does have a dark side. Our addiction to cheap energy consumption and easy living could put our planet and species on an irreversible collision course with an apocalyptic future. And on the west coast of the United States, the warning signs are flashing.
We're seeing an increase of both the frequency and intensity of wildfires on the west coast of North America, right up from British Columbia down to California.
No jurisdiction has suffered as catastrophically as California.
California has a long history of wildfires. However, in recent years, they've increased in frequency and intensity. California has also been suffering prolonged periods of droughts.
The 2018 Camp Fire was one of the deadliest, killing 85 civilians and completely destroying the towns of Paradise and Concow.
As conditions become more intense, as we're seeing a greater duration of these droughts persisting, unfortunately the trends are indicative that this is going to be something that persists over time. And we're seeing that these are happening and having more and more catastrophic impacts on the surrounding communities.
Early in 2020, there was concern for fire season to be prolonged and especially grave due to the unusually dry months of January and February, one of the driest such periods of any calendar year on record.
The state had so many fires going on, and fire suppression efforts weren't being successful. Eventually, the fires began to overlap with one another, burning out of control.
On the early morning of August 17, 2020, thunderstorms carried northward from the weakening tropical storm Fausto moved across Glenn and Mendocino counties.
Tropical storm Fausto, all it did was bring a big plume of moisture up towards California, which triggered a ton of dry thunderstorms. It didn't produce much rain. What it did produce was a ton of lightning, and that lightning set off a bunch of very large fires.
This storm started at least 13 fires covering 40 hectares.
The 2020 fires spread across the landscape, including one that became known as the Doe Fire, 220 hectares in size, but that began to spread and began to grow larger.
Over the next 2 days, hot, dry weather and gusty winds caused the fires to explode in size.
There were now over 360 separate fires burning. The governor declared a state of emergency.
Every day, the fires grew as fire crews battled the blazes.
Several weeks later, what used to be multiple hundred small separate fires have now coalesced into what's called a fire complex. Some of these are burned out areas and some of these are active fire fronts.
By September 4th, the combined fires had reached 120,000 hectares, or 12,000 square kilometers, making it twice the size of the 2018 Camp Fire, devouring over 80 square kilometers a day.
The fire continued to grow in size in terms of the entire complex. Hundreds of small fires is now a giga fire, which is classified as 1 million acres or more. This is one of the largest fires that California has ever seen.
The 2020 wildfire season was record-setting. By the end of the year, 9,917 fires had burned an area about the size of the country of Wales.
The damage was unprecedented. Over 10,000 structures burned and over $12 billion of damage was sustained. Over 4% of the state was engulfed or involved in this wildfire.
The damage was exacerbated by the extensive overlap of residential and industrial areas with the natural realm. What factors are causing these wildfires to grow bigger and more destructive? And is there anything we can do to stop them?
The amount of activity taking place along the West Coast is pretty substantial, but it's also a part of the continent where we see a lot of food production and economic activity taking place. There is a risk there with all this activity being concentrated in such a fire-prone area. When these fires do arise, the consequences are not just natural and destructive to the environment, but they have cascading implications through food chains, supply chains, and a myriad of other critical human activity that's taking place.
Fire on its own is actually a natural part of the forest ecosystem. Fires are necessary to sometimes clear up the dead underbrush. It's a part of what should be a natural life cycle.
Indigenous peoples had stewardship of the land, and they knew that prescribed burns had to occur. There are some plants that can only reproduce if there's been a fire, for example. Settlers would come in and they felt that fire was bad. All fire was bad. This has resulted in certain areas of California being extremely flammable.
Humans have altered the natural landscape through logging and through different land use. The forest is now somewhat out of balance. We've created artificialities in the system.
Increasingly, what we're seeing are what are called wildland-urban interface fires. We have now allowed development in forested landscapes. We're allowing new cities, new towns in what are fire-dominated landscapes. Instead of seeing, oh, it's a forest fire where we just lost timber, it's a fire where we lost 3,000 houses or 6,000 houses.
The natural environment catches on fire every once in a while. Your home is not supposed to catch on fire once in a while. So that's really this perennial problem we have. You are going to keep seeing this. This is not something that's going to stop anytime soon.
When we think about the contributing factors to the increasing wildfire risk in California, certainly climate change in the Californian area is expected to warm the average conditions overall and to make those conditions more dry. Overall, we expect to see warmer, drier, windier conditions under climate change.
What's driving climate change? Human activity.
Climate change comes down to human emissions of greenhouse gases, and those coalesce in the atmosphere and trap heat that's potentially re-radiated from the Earth. That becomes now an insulating blanket, and in general, the average temperatures rise. When we bring that down to the regional level, California, like many other places on the planet, has been setting temperature records. It's unfortunately very common to see the top 4 temperatures ever recorded being found in the last 20 years.
Fighting climate change is a daunting prospect, complicated by human economies and human nature.
When it comes to climate change and the individual things you can do to mitigate it, you'd like to think that every individual is rational. We're not. You'd like to think that people will do things based on their ideals. We don't always. So when you talk about something like climate change, it's going to be catastrophic. The catastrophe is always years away. So why aren't more people doing things they can do in this day and age to reduce fossil fuel consumption, lead cleaner lives, and have less of an impact? Because the costs that may be associated with them. We'll always find the decisions made for today will outweigh decisions made for tomorrow. It doesn't mean that people don't care, but big sweeping changes all at once require support and resources. And that's what makes a lot of the changes necessary difficult.
As long-term climate solutions remain abstract and uncertain, practical local intervention has never been more urgent.
Number one is reducing emissions of greenhouse gases, and that's been known and understood for decades now. And that will translate in a very long-term sense into less and less climate change. We have to hold the line at some level.
One of the things we need to do is look at different land use management practices that are out there. There's a lot of traditional knowledge out there that could be drawn upon. In many cases, there are actually indigenous practices that go back many thousands of years.
To help clear dead material, some in California have reached out to an unlikely hero.
There are also innovative solutions, such as the use of goats in some areas. Now, that's one that could be further explored, but we need to consider all potential outcomes.
Goats are generalists and they can be very detrimental to the environment. The idea that they would be able to come in and eat all that highly flammable grass in principle makes sense, but I would urge a lot of caution because whenever you bring something in, you very often don't get the results that you're expecting.
The last thing you want to do is introduce a species that could become invasive. However, proper land management is something that we know could help us stem the tide that's rising against us with increasing fires.
California continues to struggle between balancing today's societal demands with future dangers that certainly lie ahead over the coming decades. Half a century earlier, catastrophe was unanticipated and instant. One town in Peru had no idea of how much danger they were in.
The town of Yungay was considered to be a tourist destination. It was a beautiful place to live for the local residents. The classic mountain scene where there's an idyllic village at the bottom of the valley and beautiful towering mountains on either side. Yungay is a town of around 5,000 people in the shadow of the Huascaran mountain. That mountain has a glacier on the flank of it, or it did in 1970.
With the notable exception of the massive stone cathedral at the center of town, the city consisted predominantly of 2- or 3-story adobe and wood structures, but it could become crowded by thousands of visitors on market and church days.
On May 31st, 1970, most of the town of Yungay was indoors celebrating the World Cup when the earth began to rumble.
The earthquake did considerable damage to the town, but what it shook loose was horrific.
That essentially dislodged or triggered a collapse on Huascaran Mountain of a massive rockfall. The biggest challenge here is the speed with which the debris flow moved in the avalanche. Traveling 13 kilometers in 2 minutes leaves you very, very little time for evacuation.
The shaking dislodged a slab of rock about 800 meters wide from the western face of the Huascaran's north peak. 800 meters is about 7.5 football fields.
When you see a picture or video of an avalanche, it looks like a beautiful, fluffy white cloud coming down the mountain, but you're only seeing the powder on top of what is essentially like cement. Add on to that a rock 800 meters wide, nothing is surviving something like that. I mean, it's going to obliterate anything in its path.
The rock fell some 600 meters vertically before landing on Glacier 511 and sliding nearly 3 kilometers down its surface, accumulating a large volume of firm snow as it went.
When the large mass of rock landed on the glacier, it essentially pulverized the glacier and mobilized huge amounts of snow and ice and water even, mixing in with the collapsed rock.
The initial ice rock avalanche volume was at least 25 million cubic meters and grew rapidly in size as it fell down the steep Yonganuco Valley, picking up large volumes of dirt, loose glacial moraine, and uprooted trees.
This then created what's often known as a debris flow avalanche. That rides on a layer of air, essentially like a conveyor belt.
The maximum volume of mud flow was as much as 50 to 100 million cubic meters, and it reached speeds of up to 435 kilometers per hour.
The debris flow that was triggered by the rockfall collapse onto the glacier mobilized very quickly all sorts of rock and material riding on a cushion of air. By some estimates, it was traveling over 400 kilometers per hour. There's no possibility of evacuation. 5,000 people laying directly in the path of that debris flow couldn't possibly have evacuated.
There was no warning. Giant rocks bounced and rolled towards Yungay, leaving huge craters in the ground and flattening buildings that had not already been destroyed by the earthquake.
And remember, there's a huge mass of this, so we have an incredibly large amount of material traveling at a really high speed. It has a huge amount of energy and a huge amount of momentum. Anything in its path really isn't going to stand up to this material.
The mud flow itself was described by survivors as rolling, wave-like, or a rolling confused motion. Practically every man-made structure in Yungay, except a few in the outskirts, were destroyed, and thousands of people were killed instantly.
The only thing that's left visible of the town of Yungay are some church steeples poking up from the debris flow deposit, but essentially everything else is covered by mud.
The avalanche destroyed Yungay and 10 nearby villages, leaving up to 30,000 people dead. It is the deadliest avalanche or glacier-related disaster in history. To understand why this disaster was so deadly, we must examine the reasons that human beings would live in the shadow of the Huascaran. The Huascaran is the highest peak of the Peruvian Andes and rises to an elevation of 6,768 meters.
The community of Yungay exists primarily because it's a valley bottom and it's an area that is possible for buildings to be built. You can't build on a steep mountain slope. In a mountainous environment, you have fertile soil and you have sediment that's come off the glacier and has come off the mountains repeatedly. So that gives you the opportunity to make a living through farming. Other members of the community, because it's such a beautiful valley, could be involved in perhaps the tourism industry. So there's a lot of reasons why people might settle in an otherwise risky area.
But the dangers of inhabiting this region were not unknown.
This would not be the first time that Yungay has experienced a landslide earthquake event. In 1872, an earthquake of a similar magnitude took place, creating the same conditions and same disaster.
In 1962, there was actually a precursor event that could have provided a lot of warning. There's a local glacier that's been referred to as Glacier 511. In 1962, a portion of the mountain collapsed and mobilized that glacier, effectively wiping out several small villages near Yungay.
But local authorities ordered this information to be retracted and discouraged citizens from speaking under threat of imprisonment.
The local government could have learned from that event in 1962 and could have carried out a risk assessment, and unfortunately the government chose not to do that.
After 1970, the dangers of the Huascaran could no longer be ignored, and scientists rushed to the area to conduct more studies. One of the most important questions was, how did the avalanche advance so fast?
When we look at the Yungay event, we have a huge amount of mass at elevation that has a massive amount of potential energy that's getting converted into kinetic energy. As that debris falls, it picks up speed. The ice and snow created almost an air cushion underneath the falling debris, reducing the friction with the ground. All of this debris was floating on air and moving nearly frictionlessly. Because of the mass and speed of this material, it had an immense amount of energy, an immense amount of momentum, and anything in the valley that it came in contact with was going to be obliterated.
The air-cushioned flow meant that the people of Yungay only had 1 minute to evacuate before the deadly avalanche hit. This fact makes pre-warning of avalanches almost useless, but other safety measures can be taken.
There's essentially no way to engineer a building to withstand a debris flow. There has been some success in building what are called diversion channels in areas where debris flows are common. Essentially what you're trying to do is channelize and move that material away from a city.
But the most effective defense remains prediction of the event.
There's a lot of lessons learned from the Yungay experience. Certainly that starts with earthquake detection and warning. But there could be situations where an avalanche is triggered even without an earthquake. In that case, you can actually detect those debris flows. Essentially, wherever that debris flow might end up in a channel, a river channel, you would put some sort of detection machine. As soon as the machine gets knocked offline, then that issues a warning to the local community.
Following the disaster, the Peruvian government conducted relief efforts and planned to move the provincial capital from Yungay to a safer location at Tingua. survivors resisted the resettlement proposal, and thousands stayed in the camp just north of the destroyed city known as Yungay Norte, which would eventually become the present-day town of Yungay.
Post-1970, the national government learned from the experience in Yungay and decided to invest quite heavily into glacier risk and avalanche risk mitigation.
Although most of Yungay was completely leveled by the earthquake and mud flows, some remnants, including the ruined cathedral and cemetery, can still be seen in the area. The government has forbidden redevelopment or evacuation of the original town site, where a memorial has been established to commemorate the dead.
They also dedicated a special day to that, May 31st, as a day to reflect on what had happened and to consider how to potentially reduce the risk of avalanche in communities.
The Yungay disaster showed that in the blink of an eye, Mother Nature can wipe entire towns off the map. But in 1945, humanity proved it too can unleash destructive power that can rival Mother Nature's worst. On December 7, 1941, Japanese forces bombed Pearl Harbor. Planes dove from the sky, slamming into the hulls of U.S. Navy ships.
In the early years of World War II, America had largely stayed out of the fighting. This attack all but guaranteed that the United States would enter the war on the side of the Allies.
In response to the Pearl Harbor attack, on December 8, 1941, the United States Congress declared war on the Empire of Japan, bringing the U.S. fully into World War II.
The Pacific Front became one of the most horrifying experiences of the Second World War. Slowly grinding from island to island, the fighting on land was particularly horrifying, often coming down to hand-to-hand combat in dense Pacific jungles.
By 1945, the United States had all but pushed back the Japanese to their home islands. On April 1st, the U.S. launched the largest amphibious assault in the history of the Pacific Theater.
The horror of the Pacific Theater is encompassed best by the Battle of Okinawa. A long, drawn-out, and bloody affair, Okinawa witnessed the deaths of 50,000 American servicemen, somewhere between 80 and 115,000 Japanese soldiers, and most horrifying of all, somewhere around 300,000 citizens of the island of Okinawa.
American planes firebombed Japanese cities relentlessly. On August 6, 1945, a Boeing B-29 called Enola Gay took off from Tinian Island. The United States wanted to end the war as soon as possible, and they believed they had the means to do so.
The crew of the Enola Gay embarked on a bombing mission much like any other.
At 8:15 a.m., the Enola Gay spotted Hiroshima.
Whether or not they were aware of the destructive potential of the bomb they carried, they flew over the Japanese city of Hiroshima and dropped Little Boy, the first atomic bomb deployed on a civilian city.
The signal was given. The bomb bay doors opened. Little Boy was dropped 9,400 meters above the city of Hiroshima. 44 seconds later. There was a bright flash as the atomic bomb detonated about 450 meters before hitting the ground.
The explosion vaporized buildings and people in the immediate vicinity of the blast.
But it wasn't just the explosive force that was deadly.
Those who were closest to the bomb site would have just basically evaporated or perished. But then as the radiation goes out, you have the radiation exposure itself, which is toxic. So those who were exposed to severe radiation, depending on how close they were to the bomb site, the radiation will dilute itself as it expands, but you're still going to have areas where there's acute exposure to radiation.
Those who died on contact were the lucky ones. Survivors were faced with radiation poisoning, full body burns, and a often slow and painful death. They also witnessed the destruction of their city. 3 days after Hiroshima was destroyed, American forces dropped a second bomb on the Japanese city of Nagasaki. Japan surrendered 6 days later, bringing a close to the war in the Pacific and an end to World War II.
Over the next 2 to 4 months, the effects of the atomic bombings killed between 90,000 and 146,000 people in Hiroshima, and between 39,000 and 80,000 people in Nagasaki. Roughly half occurred on the first day.
The first thing is bright flash. That shockwave knocks down buildings, literally blows most of the wooden structures away. And then right behind that shockwave is the fireball, the intense heat and additional radionuclide radiation that are going to cause people to have cancer and radiation sickness later.
For months afterward, many people continued to die from the effects of burns, radiation sickness, and injuries, compounded by illness and malnutrition.
At the time, it might have just been, well, wow, I am so lucky to have survived. But over the years, more and more evidence is coming out that people in these other zones were exposed to radiation, and they were developing cancers, and they were dying from it.
Though Hiroshima had a sizable military garrison, most of the dead were civilians. How was the atomic bomb so destructive? And why were these two cities chosen to demonstrate their apocalyptic power? The bomb contained 64 kilograms of enriched uranium.
We have a uranium core, so this is before we have plutonium. But as we put more and more uranium closer together, atoms release neutrons, and those neutrons hit other uranium atoms, causing them to undergo fission. And when those uranium atoms undergo fission, they release more neutrons, and those neutrons impact more uranium atoms and cause more fission. And if we get enough uranium close enough together, we get a sudden cascade reaction, and all of the uranium undergoes fission, or a huge portion of it, all at the same time, and we get a nuclear explosion. So the engineers spent a lot of time figuring out how to create a bomb that put all the pieces of uranium in a close enough proximity for a long enough time that it underwent that cascade reaction.
Less than a kilogram of uranium underwent nuclear fission, and of this mass, only 0.7 grams was transformed into several forms of energy, mostly kinetic, but also heat and radiation. The theory behind harnessing this power has its basis in Einstein's theory of special relativity.
His famous equation E equals mc squared basically says that mass has an equivalent in energy. Energy is equal mass times the speed of light squared. What happens in a nuclear reaction is when uranium undergoes fission, the two atoms that are produced from that fission weigh less combined than the original mass of uranium. So some of that mass is being converted to energy. We end up with a huge amount of energy being produced, and that's the basis of why nuclear bombs are so powerful.
Einstein's revelations about the energy inherent in matter, together with Marie Curie's discovery of radiation, would become the building blocks for the nuclear age.
In the context of something like a nuclear bomb, of course, radiation is not good. And so some might argue that this, radiation should never have been discovered. But radiation also has its purposes. We have X-rays because of radiation. It's controversial, but nuclear energy is considered a potential form of energy to replace fossil fuels. Has it been weaponized and used for things that it should not be used for? Yes, it has.
Less than 3 decades after Einstein unveiled his famous equation, Robert Oppenheimer, director of the Manhattan Project, would witness the first nuclear explosion. He would cite a piece of Hindu scripture that would become ever linked to the birth of our nuclear age. Today's weapons have even greater capacity, enough to destroy ourselves hundreds of times over.
Research and development in several areas promise more powerful warheads, longer-reaching weapons, and simultaneously reduce the defender's chance against them.
Fat Man and Little Boy used naturally occurring uranium that was enriched as the fissile material. Plutonium has a much higher radioactivity than uranium, so we can build smaller and more powerful bombs. We can actually put hydrogen inside our bombs and fuse it and turn our fissile bomb into a fusion bomb. And we can make it thousands of times more powerful than the horribly powerful weapons that we had in World War II.
We've never, for thousands of years, really been worried about the loss of our entire species. And yet now here is a threat of a war that would. Having that growing up with it, that's going to affect you. That's going to be something you remember. And it's going to set your own beliefs and your own fears about nuclear energy, nuclear war. But then the Cold War ended. And generations have come since then who've never had worry about a nuclear war happening. And so that's not on their agendas.
Despite that threat receding, it can never again be fully dismissed. In 2022, Russia's invasion of Ukraine and the unprovoked threats that accompanied it led to renewed speculation about the horrors that Russia, or any of the world's nuclear powers, could potentially unleash. Today, nuclear war is just one of the many potential disasters that compete for space in our collective consciousness. From socioeconomic fears to health crises and natural disasters, we have a lot to consider. Today, fear of nuclear winter has largely been displaced by apocalyptic visions of our warming atmosphere.
In the latest generation, it's climate change instead. So it's a change in what could destroy the planet. But it almost seems like we have an expectation to have something that we worry about ending the world. But we might not be able to manage more than one at a time.